Dear Calc 2 students, in this video we'll see how to deal with integrations with partial fractions when we have the denominator that has some repeated factors. So if you look at the first one, we have the integral of 12 over x to the third power minus 3x squared. Well, of course, go ahead and just factor the denominator. In this case, we can factor out the x squared, so we get x squared times x minus 3. Okay. This right here looks like a quadratic, but technically you can also look at this as x times x. So it's a linear factor, but it's just repeated twice. And the way to break this down is the following. I'm going to write this down right here on the side for you guys. I'm going to put down 12 over x squared times x minus 3, and this is what we do. Remember this, whenever we have a repeated factor, again this means x times x, we have to build up the power. So first, we will have x to the first power on the bottom, and then because this is to the second power, we will have to just go up to the x to the second power. If this is x to the fifth power, then you just go x to the first, x to the second, x to the third, x to the fourth, x to the fifth, right? But I won't ask you guys that questions on the test, don't worry about that. And you also have to remember, when we do this, the top stay the same kind. You see that right here, we have a linear, right? It's x to the first power. So on the top, it's just a constant. And the top stay the same kind. So this will also be a constant whenever we build up the power, right? Whenever we build up the power. So we have this and that. And then lastly, we have this denominator for the third fraction. So just say plus x minus 3 here. And then on the top, because this is linear, so we just put down a constant c. And let me just go over why this is the case. Well, you can also break this apart as, if you don't want to build out the power, then you just put this down as x squared here, and then plus this right here is x minus 3. Again, we are not building out the power, right? If you don't want to. But if you don't want to do that, this right here, you have to look at it as a quadratic. That means the top should be a linear. So you will have to put down ax plus b. So let me just write that down. And of course, this is going to be a constant. But you see this guy, we can split the fraction. So we are looking at ax over x squared and then plus b over that. And of course, we still have this guy, c over x minus 3. But what can we do for the first fraction? Well, as you can see, this and that cancel. And that's exactly why we need the a over x. All right? So anyway, just go from here to here. That will be it. You don't have to do this every single time. Build up the power and the top stay the same kind. And now, good news for you guys. We can actually use the calc method for two letters, b and c, because we see this denominator right here. And likewise, we see this denominator right here. So b and c, we can use the calc method for that. So let's go ahead and do them first. So let's do b. Well, b is going to be equal to, we go back to the original and we cover the same denominator. And how can we make x squared equal 0? X has to be 0, right? So I'll just put down x is equal to 0. And we cover this up already. So we put the 0 into this x only. And we are looking at 12 over 0 minus 3. And that will give us negative 4. So b is equal to negative 4. And I think that's pretty good. Now for c, this is going to be, well, come here, cover this up, when x is equal to positive 3. So let me just put that down real quick. And we cover this up already, so we put 3 right there. So we are looking at 12 over 3 squared. And this right here is going to give us 12 over 9, and that will give us 4 over 3 after we reduce. So we have the b and c value, which is pretty good. So this is 4 over 3. Okay, not so bad. Not so bad. Now, let's see how we can figure out the good old-fashioned way. So let's go ahead and look at this and multiply everybody by the lowest common denominator, which is just this guy. So x squared times x minus 3. And we are looking at this times that, we just have 12. And this times that, well, one of the x cancel, so we have x times that, so we will have a, which we don't know yet, x to the first power times x minus 3. And let me just fix my exponent 2 right here real quick. Okay. Okay, next we do this times that. The x squared cancel, so we will just have the b, which is negative 4, times that, which is x minus 3. And lastly, this times that, the x minus 3 cancel, so we just have this, which is 4 over 3 times x times x squared right here. Oh, it fits everything, so that's nice. Alright, now again, just like what we did in the previous video, just go ahead and multiply this out and try to look for what a is. Okay, here this is going to be ax squared and minus 3ax, and then in fact you don't really need to do anything, but like let me just finish this real quick. Let me just finish this. This is minus 4x plus 12, and lastly we have the plus 4 over 3x squared. The reason I said we didn't really need to do too much is because we can just look at this and that. This right here will give us a plus 4 over 3 times x squared, and then other stuff. We really don't need any of them anymore, because this right here tells us, because on the left hand side we pretty much have 0 x squared, right? Because there was no x squared term in the first place. So that means the coefficient right here is 0, so this right here should be 0. A plus 4 over 3 is equal to 0. That means a has to be negative 4 over 3. So we can just come here and say a is equal to negative 4 over 3. Done deal. Cool. So now, to integrate this guy, it's going to be the same as integrating the first guy, which is negative 4 over 3. I'm just going to write it down like this. Negative 4 over 3 over x. Next, we have negative 4 over that, so we will have the minus 4 like this, over x squared, and then that guy is going to be plus 4 over 3 over x minus 3. So that's about all, and then perhaps I'll put on a dx right here, and just to make more people happy, I'll put on the parentheses over there. And of course, we'll just finish everything, right? Let's just go ahead and integrating everybody. First guy, negative 4 over 3 ln absolute value of x. Next guy, well, let me remind you guys this real quick. We do have a constant multiple 4 right here, so we can put that down. But I will remind you guys the integral of the 1 over x squared, which is going to be x to the negative 2. This right here, we do the reverse power rule. We add 1 to the power, which is going to be negative 1, and divide it by this power, so we will have 1 over negative 1, and this is going to give us negative and x to the negative 1 power. So let me just write that down, and that's going to be negative 1 over x. So as we can see, this right here is negative. But if you look at the integral of 1 over x squared, we get negative 1 over x. Negative times negative will give us positive right there. Alright? And then of course we can also put down the over x like this. Okay, so this integral is going to give us that. And then lastly, we'll just add 4 over 3, and then again the bottom is just linear, so ln absolute value of x minus 3. Whew, we are all done. After we put down the plus c, this is it. So take a look right here real quick. Okay, question number 2. The denominator has been factored for us already, which is very nice. So we can just go ahead and do the partial fraction. And of course, let's do it on the side. We are looking at 3x minus 5 over x plus 1 times x plus 2 squared. So right here, this is the repeating factor, right? First, we will have this for the denominator, and that's just x plus 1, and the top will be just a constant. And for this part, we will have to build up the power. So we are going to have some number over this, which is x plus 2, and then some other number over x plus 2 square, right? We put out the power. And I said this is a number and this is a number because, well, this is linear, that's why, and then the top stay the same kind. So let's put down b and c. So that is what we have. And now let's multiply everybody by the, well, actually no, not yet. Let's get a and C by using the cover-up. So here we go. To get A with the cover-up, well, this is what we do. The denominator here is x plus 1. We go back to the original, cover the same denominator, and how can we make x plus 1 equal 0? X has to be -1. So we will put x equals -1 into this x and that x. So we get 3 times -1 minus 5 over -1 and then plus 2. And then we square. On the bottom, this is just one square, which is 1. On the top is going to be -3 minus 5, which is -8. So A is equal to -8, which is very nice. All right, now let's do C as well. And the reason that we can use C is because this denominator is exactly the same as this one, right? So we cover this up, and how can we make this factor equal 0? The answer is x has to be -2. So we just let x equal -2. Put it here and put it here because we covered this up already, and we get 3 times -2 minus 5 over -2 plus 1. On the bottom here we get -1. On the top right here we get -11. So altogether we get +11. So C is +11. Okay. So that's what we have. And now to get B, let's see what we get. Okay, multiply everybody by the common denominator, which is x plus 1, x plus 2 square. This times that, we just get the numerator, which is the 3x minus 5. And then when we do this times that, the x plus 1 cancel, so we get the -8. And we will still have to multiply by this guy. So it's slightly longer for this question. So we have x plus 2 square. And then this times that, one of the x plus 2 cancel. So we will still have to have this, which is, let me just write down plus b. And we get this right here first. So x plus 1. And we still have to multiply by another x plus 2, right? Okay. And then lastly, we do this times that, the x plus 2 square cancel. So we just have the c, which is +11. And we have the x plus 1. Yeah. You can just go ahead and multiply it out and solve this. Well, you can also let x equal 0 and then just try to figure it out. But I want to be consistent, so I will just multiply this out. I think from my experience, you guys can follow along this way better. I know it's just a lot of algebra, that's all. Yeah. So what are we looking at? This right here is equal to -8. And then this right here, when we open it, we get x squared plus 4x plus 4. And then let's multiply this out first, yeah? So we get plus b. And then this right here is going to give us x squared plus 2x plus x. So that's plus 3x. And then plus 2. And then, of course, for this guy, we can just distribute. So we get plus 11x plus 11. And right here, we just distribute. But in fact, we just need to worry about this and also that. And the reason is because they will produce the x squared term, right? So we will look at -8x squared. So let's look at it like this. And then bx squared. So I'll just put on plus b. And then we have the x squared term. And again, we don't really need to worry about what's after that. And as we can see, on the left-hand side, we do not have x squared. So that means we have 0x squared, right? So that means 0 is for this. Okay, so this guy has to be equal to 0. That means b has to be +8. Oh my god. This is my b and this is my 8, right? So that's the idea. Cool. Now we can, of course, just do the usual business and finish this question. So let me just write this down. This is b equals 8. Ladies and gentlemen, let's come back here. We have the integral right here, and the first one is -8 over that. So let me just write that down. -8 over x plus 1. Next, we have +8 over that. So plus 8 over x plus 2. And lastly, we have 11 over that. So plus 11 over x plus 2, but to the second power. And then right here, we'll just close the integral with the dx. And again, let me just put down parentheses to make people happier. But yeah, we're ready to integrate. For the first one, that's a constant multiple. On the bottom, we have a linear factor, so that will give us ln, absolute value of this. And the coefficient right here is 1, so we didn't have to divide anything. Continue. Next one, positive 8, so plus 8. And then ln, absolute value, x plus 2. Now, for this guy right here, we have the positive 11, so I'll just put that down. Actually, not yet. Let me show you guys this first. We have the 11, right? And then we have that. Let's just focus on the integral of 1 over x plus 2 square. To integrate this, we do u sub, let u equal the denominator, which is x plus 2. Actually, just the inside. We don't want it to be the second power. And we'll see this is just du equals dx. And we see this is just going to be integral 1 over u square du. This right here means we get the integral of u to the negative 2 in the u world. So integrate this, you add 1 to the power, we get negative 1 and divide it by the new power. So we get negative 1 over u because we have the u to the negative 1. And u is x plus 2, right? So we just put that down. Yeah. Anyway, earlier it was plus, but right here it's a minus. So we actually have a minus here. And then we have the constant multiple 11. So let me just put that down here. And let me just put down this in blue. Yeah, because we integrate this, right? That's the negative integral right here. And we have the over x plus 2. So over x plus 2. Yeah, so just like this. So perhaps I'll just write it down slightly better for you guys. Minus 11 over x plus 2. Okay, and we're all done. After we put down the plus c, this right here is it. Yeah, so take a look at all this. All right, number 3 right here. And okay, number 3 here. Again, the denominator has been factored in for us, which is very nice. On the top, degree is 2. On the bottom, degree is 2 here and then 1 here. So when you multiply, you add the exponent. So the degree is 3. We don't need to do long division, but we still have to do the partial fraction. Okay, so let's go ahead and work that out right here. So let me just write that down again. X squared plus 7x minus 3 over 2x plus 1 times x minus 2 squared. Well, this right here will be going first, right? 2x plus 1. Because this linear on the top is just going to be constant. And then we add. Here we will have to build up the power. So we start with x minus 2 here to the first power. On the top, it will be a constant. And then right here, we will have the x minus 2 squared. On the top will still be a constant because we are building up the power. All right, again, good news. We can solve 2 letters by using the calc method. And that will be a and c. For a, well, this time slightly trickier. Because the denominator is 2x plus 1, we come here and we cover this up. How can we make 2x plus 1 equal 0? X has to be negative 1/2. So x is equal to negative 1/2. And we will just have to plug this in into all the x's. And just deal with fractions, I know. Okay, let's see if we can handle that. Right here we have negative 1 over 2 square, and then plus 7 times negative 1 over 2, and then minus 3 over, this right here is negative 1 over 2, and then minus 2, and then to the second power. All right, so let's see. This is going to give us positive 1 over 4, and this is going to give us negative 7 over 2, and then minus 3. And on the bottom, this is going to give us negative 5 over 2, right? Because you just get the common denominator all worked out, and then you have to square that. So when you square that, this is just the same as 25 over 4. So what we can do is just multiply the top and bottom by 4. Why? Because this way, we can just get rid of the complex fractions. I think it's easier that way. So if you do this times that, we get 1 minus this times that, reduce it, you have 2 times that is 14. This times that is 12 over this times that, we just get 25. Okay, let's see. This minus that is negative 26 plus 1 is negative 25 over 25. Hey, what do we have? Yeah, work this out, we will end up with negative 1. I know, all the work for negative 1. Yeah, but it's just arithmetic, so not so bad, right? Not so bad. Alright, continue. We use the carve-out method for C. Right? A is negative 1. C is going to be the following. We go back to the original, cover this up, and how can we make x minus 2 squared equal 0? X has to be 2. So let me indicate that right here. And then we will just put a 2 into the remaining x's. Here we will have 2 squared plus 7 times 2, and then minus 3 over 2 here, so it's 2 times 2, and then plus 1. Okay, again, let's just work this out. This is 4 plus 14 minus 3 over 5, and this is 18 plus, sorry, 18 minus 3 is 15 over 5. Yes, and then this is going to give us positive 3. So C is also really nice. So here we have C equals 3. All right, now for B, yeah, we just have to do it the good old-fashioned way. Again, it's just because I think it's more consistent, it's more clear for the students, for you guys. So yeah, let's multiply everybody by the common denominator, which is just that. So let me put down 2x plus 1, x minus 2 squared. This times that, we'll just have the top right here. So let's look at here, x squared plus 7x minus 3, that will be equal to, this times that, the 2x plus 1 will cancel, so we have negative 1 times this, which is x plus, sorry, x minus, so be really careful, you see? Yeah, x minus 2 squared. I make mistakes too, so just be really careful for that. Alright, and then for the next one, b we don't know, so put down plus b, and then one of them cancel out, so we will have this and that. So b times 2x plus 1, and then x minus 2. And lastly, we have the c, which is 3. This and that cancel, so we just have that right here. So 3 times 2x plus 1. Whew. Alright, so just work this out. Here we will see this is negative, expand this, we get x squared minus 4x plus 4. And again, let's multiply out the binomials right here. So we get plus b. Okay, 2x squared. And then this is going to give us negative 2x. And then negative 2x. And then plus x. So together we'll get negative x. And then minus 2. Right, when we do this times that. And of course, on the bottom, in fact, it doesn't really matter, but I'll multiply it out anyway. Plus 6x plus 3. What it really matters is the coefficient of x squared, right? Again, just like what happened earlier. So we see this times that, we end up with negative 1, and then plus 2b times x squared, and then seriously, the rest we really don't care. Well, you see on the left hand side, this time the coefficient is 1. Right? The coefficient is 1. And the coefficient right here is this. So that means they must be equal. So we will look at negative 1 plus 2b equals that, which is 1. Move this to the other side, which is 2. And you know what? B is just equal to 1. Oh my god. All the work for b equals 1. Yeah. Alright, so now we go back there and then we will just integrate. So here we go, look at the integral, and then first fraction is negative 1 over 2x plus 1. Next fraction, we have 1 over that, so we add 1 over x minus 2. And then next, we have 3 over that, so plus 3 over x minus 2, but to the second power. Yep. And then, of course, just put on parentheses to make people happy, and then dx. If you don't have the parentheses right here, I'm cool with that. Yeah. But anyway, here we go for the first one. We get negative, right? And then on the bottom, it's linear, so we get ln absolute value of 2x plus 1. And what else do we need? Here we have the 2x plus 1, so we will actually have to divide it by 2. So just put down negative 1 over 2, like that. Remember the formula. I'll put this down right here real quick. When we have the integral of 1 over ax plus b, right? This right here gives us 1 over a ln absolute value of ax plus b. So that's why we are dividing by the 2. So that's what we have for the first part. Next, this is just 1, so it doesn't really matter. I'll just say we add ln of the bottom x minus 2. And the coefficient is 1, so it doesn't matter. Lastly, we have the 3 over that, which is very similar to what we did earlier. So I'm just going to do that again for you guys real quick, all right? So, well, actually, you guys do it. Or should I do it? You should do it. This right here, I'll just tell you, right? Look at what we did earlier. When you do u sub, you end up with negative for the result for the integral, so it becomes negative, and then we have the 3. So perhaps the negative should be in blue to make it more stand out. We have the negative, the 3, right? The 3, over just x minus 2. All right? Very similar to what we did earlier, and we're all done. Put on the plus c. All right? So this right here is it. Huh? You want me to do it? Okay, I will do it for you. This right here, just look at the blue part, all right? So let me just do that for you guys real quick again. So when you have the integral of 1 over x minus 2 square, you do the u sub, you let u equal the inside here, which is x minus 2, and du is equal to dx. So this right here is just the integral of 1 over u square du, right? And then we're not looking at the bottom right here. This right here is the same as integrating u to the negative 2 in the u world. And again, you see, we add 1 to the power. That will give us negative 1 for the new power. Divided by the new power, put it right here. That's why it becomes negative. And if you look at, we get a negative right here, and then u to the negative 1, which is 1 over u, and u is x minus 2. And that's why we have this part. And then this 3 is from here. All right? So just do the u sub on your own whenever necessary. All right, so hopefully these videos for partial fractions are helpful. If you need help with calculus, you guys can subscribe to my channel, watch my other videos for integration or calculus tutorials. As always, that's it.